one quick overview before I go into actually manipulating these interfaces is what you're going to see on this demo is we're going to install EVE-OS onto a piece of bare metal that is not in my possession. It's actually hosted by Equinix Metal in one of their data centers. We're going to install EVE-OS magically. I call it magically. When Roman first showed me this and I got it to work, it was like, wow, this is so cool. Using iPixie. And so what Equinix Metal does, just on their user interface, I can take a configuration file that tells iPixie exactly what I want to install on that server, and it just goes through those instructions. And that configuration file is just open source on the EVE GitHub, source code area. And so we're going to be walking through that where I just put in on the left here, you see the iPixie config. I just splat that URL of the config file, which is hosted on GitHub. And then you'll watch as we boot from GitHub's config file, and it brings up the server. And then I just have to, the one tricky thing is that normally you get EVE installs itself and generates a unique sort of soft serial or hard serial that is unique to that device, and we use that on the controller side to register or onboard that edge device. That's a tricky thing to do in this instance, so we have a little trick that we do with the configuration where we say, well, when that EVE-OS boots up, it gets a public IP address. We're going to use that IP address and quickly onboard it temporarily, and then it shares its unique soft serial or hard serial, and that's how we can pull it into our own controller domain before anyone else has a chance to snag it. Anyway, that's essentially the gist of the demo. So let me just stop sharing that and start over here with, let's see, whoops. Okay, here we go. So I am logged into my Equinix Metal account, and I just want to briefly show you another screen here. There is again on GitHub for EVE-OS, there's in the docs folder, there's something called deployment, and it talks about all the different ways that you can deploy EVE-OS onto your hardware. And one of the methods is, USB stick installer and BIOS, and you have a lot of great documentation. The other method here that we're going to show you is deploying it using iPixie on the bare metal. So right on this file, you'll see that current version, and it may be up to a new version, but the 6.10 version of, let me get the H in here, of this config file here, we're going to use that script, and there's a little documentation here to show you when I'm going to do it, but I'm going to do it live right now. So what do I want to do? I want to install EVE-OS onto one of these servers in a data center that is off somewhere else. And so this is the way that IT service managers can install or can upgrade EVE-OS. Usually it's installed before it goes into the field, but this just shows you that trick. I'm going to pick one nearby in Silicon Valley. I'm going to take their cheapest version of the server. And by the way, most likely, I'm going to install this in our tech lab. Most likely we'll have Vignesh, when he does the Azure IoT Edge demo, just use this same server to install and deploy an application to it using the Azure IoT runtime, or install the runtime. So here's my config file that I fetched from GitHub. I paste that into the iPixie script URL for the custom iPixie boot. I'm going to rename this just slightly so I can recognize it. Transform. Like I said, I'm going to use the smallest of these. I just took out the old one. This is my transform demo server. I really don't need anything. Alternative to using this config file is you can put the entire iPixie config information as add user data. That's another way to do it. And then I just simply click deploy now. And poof, it says it looks like, we're waiting to bring it up. And it already gives me an IP address right here. You see that IP address? That's fancy schmancy, ready to rock and roll. Now the next thing, while I have that IP address, then I need to bring in to my other screen. This is now the ZEDEDA ZEDCloud or Z-Control interface. And here's the just dashboard when you log in. This is just hosting a bunch of nodes in our tech lab. But if I want to add an edge node, I can either just go right here and add an edge node or go to the edge nodes page. And this is how I'm going to onboard it, knowing that unique IP address and something else special called an onboarding key. So we're going to do the transform demo T1. That'll just give us enough information here. So it's Equinix metal T1.small.x86. And you can add tags as a way of, clustering different things. You do have to pick a project. I don't know if I should pick a project. Maybe Vinyesh's Azure project, since he's going to be doing a deployment to that later on this morning. And you can enter a bunch of tags so that you can cluster groups of edge nodes in different ways. Asset IDs and locations, again, for tracking all of your edge nodes. I'm just going to skip that part. And then an identity type, I don't know if you can read the font here, but there's edge node certificates, onboarding keys, and then doing it later. I'm going to use the onboarding key approach because this is one of the ways that, at least for demonstration purposes, we have already generated our own private key. It's in the EVE-OS edge instance, and we know about it. So I'm going to go fetch that onboarding key right here. I'm going to copy that and stick it in here. Oops, that's not what I want.
Yep.
That's not it. I didn't get the actual copy. Hold on. Okay, not liking that. Let's try that again. Just highlight this. I thought I was highlighted, but okay. Now we get the onboarding key. And now that serial number, like I said, the trick is this iPXE. You can see that my server is up and running. I'm going to fetch that IP address, go back and stick that in as a temporary serial number. And then I have to know what I'm trying to connect to. So I happen to know that this instance on Equinix Metal is a super micro, and sometimes we have the packets. I think it's something close to this E10098 BP, I believe. So that's going to be my model. And then there are certain things you have to do in terms of who gets to use various interfaces. And this is one of the key things that IT people get to manage, is like what applications, what services get, of the Ethernet, the networking ports, the USB ports, everything that's available on this device, who gets to use it. And so I'm just going to assign both of these Ethernet interfaces to management, which is the ZEDCloud management. And then you can decide whether the audio, the comms are app direct, app shared, management, meaning, ZEDCloud. You have all of these different things. I'm just going to leave the defaults. And if Vignesh for his demo needs to change them, he can just come in here and change them. Again, neither of us have physical access to it. And then if I add this down here, this edge node, then now the controller says, hey, I'm going to go out and I'm going to look for this node, and I'm going to try to talk to it. And if you listen to the security panel later, you'll find out that right now, here's my transform demo T1. Right now, there's a whole bunch of secure, encrypted, X.509, a whole bunch of secure messages going back and forth and handshaking to establish this connection, and then communicating information and then bringing it online. And I want to go back over here to the Equinix Metal interface and just show you very briefly that while I'm looking for it, you can also watch from this side This is my on-demand server. This is its networking information, its description. It has a unique ID. That's another thing we could probably use for the onboarding. It was loaded with this iPixie script, and it's in this location in this data center. And now I'm being charged 7 cents an hour to rent this server. That's okay. It's not too bad.
But I also wanted to, Katie, I also wanted to point out that it's kind of interesting that if you just deploy an operating system on, Equinix Metal, right, you don't really have any control points into it, right? I mean, you may be able to SSH if you're lucky, but you don't actually get to see like what's going on, right? It's a very, and that's a very typical scenario in any kind of a data center, right? And I think, one of the things that people really appreciate about EVE is that it's basically an operating system with a control point, right? It is something that you can then operate from the controller, as opposed to sort of doing, SSHing and, laying out your scripts and, running your Puppet or Chef. It's a very different way of running an operating system.
Oh, but I spoke too long over there on the Equinix page. When I come back to look at the status of my node, it is now online and onboarded. It's been found. It's booted. Now I could upgrade its EVE-OS image, and I could do a whole bunch of other things. So now that we have this node online, we can we'll soon see some statistics about it. But it shows which of the images is loaded. There's no apps loaded to it yet or volumes attached to it, but it's online. Now everything I can do, I can do centrally. Again, my edge node is deployed, and all of these things can be edited or changed later for deploying different things. I know its IP address. I know what type of device it is. And you can come in here and also see events or logs. So you can see that when it was created, that it was registered, goes through various, it doesn't have the TPM for the type of hardware root of trust that some of the other devices have. It doesn't have a hardware node, but it's basically up and online and ready to go. Now,
and it still kind of blows my mind that basically what we just did, what Katie just did, is effectively installed an operating system on a piece of bare metal, from GitHub. Like that, literally, what has just happened, right? So people keep talking about, CI/CD pipelines and continuous delivery of microservices. This is the same, but for very sort of fundamental operating system. It's kind of cool if you think about it.
So now, on your dashboard, you'd see one more edge node has come online, and you can see these different nodes have applications deployed to them. This one, if I look in my edge nodes list, I see Transform Demo T1. It now has a serial number that's actually unique to that box. And I can see that this data center must be somewhere in Sunnyvale. That's where it's tagged, probably by its IP address. And again, you can click on that and do more things. The interesting thing, like later today, you'll see Kubernetes deployed through the cluster instances on some nodes. And the Azure IoT demo, just to give you a hint how that works, is under the marketplace, you have all of these applications that are ready to be deployed. So Azure IoT and different virtual machines for Ubuntu and other things. You can create these applications on your own, and there's a set up here on the top of this marketplace page of applications that ZEDEDA makes available to all of our customers who get the ZEDCloud controller. You can see AWS Greengrass and Azure IoT and a VM for CentOS and EdgeX Foundry, another Linux Foundation application, and FogLamp, which is the commercial supported side of Fledge, Ignition Edge, K3S Runtime, Mosquito, which is an MQTT broker, Node-RED for MQTT or HTTP, Center Gateway, Ubuntu VM, and Docker Runtime. But I've even created, on my own, if you go in here, you can click plus, and you can decide, do you want to create your own Edge app for your own business, containers, a VM, or some sort of module, and you define the steps. Usually, I'm skipping ahead. Usually you start with the library where you actually go and post application images. This is where you would find Docker containers, and you describe where they're coming from. We have a data center full of containers, but then you'll see that people can find them from Docker hubs, like the Fledge demo is coming right from Docker Hub. And those then get assigned as applications to the Marketplace app. And on the app, you can configure your networking, what resources you need, how much memory, CPUs, all of that stuff gets defined. And so that the role of DevOps or IT sets these up, and then the DevOps people get to use and deploy all of their other applications, especially if it's Kubernetes. They just go to town as if they're working all in the cloud world, and yet these nodes are being deposited in retail locations and energy and oil and gas and all these other places. So this is what you get to play around with if you join the developer program, is easily deploying apps like you are acting in the cloud, but you're actually deploying them to the edge. So on the EVE side, I didn't know, Roman, if you wanted to walk people around one of my favorite places to look around is, let's Edge EVE, is the documentation folder of the LF Edge Project EVE. If you click on Docs, there is just an extreme wealth of information in here. And it's all tied together. Basically, there's a lot of hyperlinks from the initial README. But I just wanted to remind you that this folder called Docs contains an extreme wealth of information about EVE, including this deployment guide that talked about the iPXE script and how you can boot from these configuration files that are loaded here. And then there are things like hardware bring-up and hardware models. And I happen to have done some edits on here. And this is where we want the community of ODMs and OEMs to say, hey, companies want to deploy at the edge. They want an easy way to do it. Pre-install EVE-OS on your hardware. So as new hardware comes up, Roman, you could talk about how you've already been hacking away on ports to RISC-V. We've got support for ARM, but as new hardware is being developed, there's these, information about how to bring up EVE on brand new hardware that doesn't even have support for it yet. Everything we're trying to do is the upstream way. So the upstream to the kernel changes, or upstream to the hypervisors, and upstream to Linux Kit, upstream to Alpine. The team here is doing things the right way, and it's well represented in the documentation here. Roman, is there any documentation file that you'd like to point out based on your descriptions?
I mean, there's actually something I would like to point out in a different folder, which is the API. Like if you could go back one level.
Yeah, that's another great one. Great point.
So as I pointed out, EVE basically talks to its controller, through the open API, and that's why it's so easy for anybody to implement their own controller, right? Just like we did. All of that API is documented in here, right? So everything and anything that you need to know about sending messages to EVE and communicating with it is basically documented in a very RFC, which is not surprising given Eric's involvement in IETF, in a very RFC manner, right? So just browse through it, and you obviously can also browse through our protobuf files if you want to see code, but all of the expectations and all of the sort of subtle points of the APIs are pretty well documented here as well.
Yeah, so this is a really well-written document about what the controller must do, what the device must do, and how they exchange it over the secure API, and how the registration, configuration, certificate passing, UUIDs, really good documentation here.
Yep. Another fun bit is kind of, if you go back to the docs folder, so another fun bit that I like a lot is basically the networking in EVE. I think it's towards the, yeah.
You want models or ACLs?
ACLs is fine. So basically, Eve implements a lot of functionality that helps you manage your networking, right? Like I said, Edge a lot of times operates under the same principles as mobile, right? Because think about it, your cell phone, it jumps between networks all the time. 1 minute it's on LTE, the next minute it, talks on the Wi-Fi, and the application is still, continuing to run, right? Your Facebook, or your Twitter app just continues to run. So obviously, all of that is done, by the operating system behind the scenes, and Eve is providing the same level of service, to its containers and VMs that it runs. And a lot of it is documented here. So, different types of ACLs and how you can, constrain the applications, talking on the network. That's actually very powerful, because a lot of it, otherwise, you would have to do in some kind of a firewall, application, right? Maybe you would have to install it inside of your actual operating system. Here, we're essentially doing all of that for you, and your application, your container or VM can be as dumb as possible.
And I've configured some of this on the ZEDCloud side, on the controller side. You can, again, manipulate these firewalls, not having to actually have access to other routers and firewalls, but the EVE-OS node is always able to talk to the controller. Then the controller can describe the environment that it wants its applications and services to abide by through all of these JSON type files are available in ZControl as as configurations.
So Katie, maybe we should spend a little bit of time answering some of the questions that I see people are asking.
That sounds like a great plan.
Awesome.
Do you want me to stop sharing, or should we?
No, it's fine. I mean,
okay.
It's actually, that's totally fine. So I'm just trying to see, so getting back to the QA box. So one question is, does Eve support 16-channel digital in and out module? Yeah, we support various, modules like that. It is more of a question of, device drivers available in the Linux kernel. We try to do, reasonable job of virtualizing some of that. So, for example, we have, I2C modules that can be virtualized, and things like that. But it all depends on the particular piece of hardware that, you're actually running. Now, again, a hardware bring up and, running even different types of hardware is actually a lot of fun. So that dovetails into another question that somebody is asking, which is, if there is one thing that, I can contribute to Eve, what would that be? Well, I personally like playing with hardware. I have my home lab that is, full of wonderful, amazing pieces of, hardware, just different kinds, right? So just, pick a box, right? You can basically pick a box. You can pick your favorite Raspberry Pi and Eve runs on it, but you can just pick a random box off of, AliExpress or Amazon and just try to see if it runs, right? That's a lot of fun. The other bit that I would recommend contributing, if you want to contribute something slightly bigger, is we actually have a few initiatives right now going on in Eve, and one of them is kind of rethinking storage layer. So again, both Eric and I come from Sun Microsystems, so it's no surprise that we're picking ZFS, Z file system, zettabyte file system, right? For one of the building blocks. And OpenZFS is actually a pretty mature project by now. So again, there's a lot of excitement in that area. The integration and how it sort of dovetails into virtualization and containers is very much not really figured out yet. So there is a doc on our wiki, which is kind of like a architecture outline of what we're trying to build. If you read through it and it sounds good to you, that's one area to contribute. And finally, there's just lots of little bits and pieces, right? And actually, Katie, maybe you can share your experience, joining the project for the first time and kind of making your first contributions.
Well, I had a Raspberry Pi 4 as my introduction to installing EVE-OS, and then I was able to actually upgrade that firmware to use the USB installer approach like the Intel boxes use. So I felt like I learned several new things by playing with hardware. Now, I'm a double E, so I can relate to having fun with hardware. But on the software side, I started reading the documentation and then noticing areas where I could help, like in this deployment of iPixie, Roman shows me how to do it. And I'm like, well, that would be cool to tell others, so I can support the documentation, support the testing, and then getting involved in the community and doing things like introducing Roman to people to get RISC-V hardware, which is fun. So I'm just a great fan of community and industry collaboration. You know, we're all trying to make the world a better place. And when we collaborate on open source, this is just a perfect example of how that works.
Yep. And that actually dovetails into one of the questions I see in the QA panel, which is, you know, do you see challenges in bringing EVE to RISC-V? Well, I mean, yes, I do, because RISC-V is very new, and actually getting access to the hardware is part of the deal. So that's, you know, why I was so thankful to Katie, you know, for hooking me up with, you know, one of the first RISC-V single board computers. So getting access to the actual hardware is kind of tricky, but you can actually run RISC-V, you know, in QEMU. That's pretty stable by now. And the rest of it is basically bringing the rest of the ecosystem. Like EVE is composed of a lot of different, you know, open source building blocks. Some of them are available on RISC-V right away. Some of them are not. I, for example, had to port a lot of the Alpine, you know, because EVE leverages a lot of the Alpine packages. I had to port a lot of Alpine, you know, to RISC-V, you know, to make it go, which actually helped the Alpine community. So we keep contributing upstream, you know, as Kathy was pointing out. But yeah, probably, you know, getting access to the hardware is the most difficult one. And there's another good question that I wanted to really answer, which is there a concrete distinction between ZEDCloud controller and an orchestrator like K3S or Micro K8S? Why an orchestrator is needed when a controller exists to control edge devices? Now, that is a great question, because in principle, you don't really need an orchestrator like, you know, K3S. I mean, that would be Rancher, I guess, but, you know, like that type of an orchestrator. There's a lot of things, you know, you can do with just ZEDCloud control or even Atom. And we actually have customers who never use, you know, any of the Kubernetes-like orchestrators or, you know, anything like that. Now, we are also not trying to replace Kubernetes, because Kubernetes does a lot of things right. And when it comes to operating, you know, complex pieces of software that are composed of multiple containers, you basically have to have an engine like Kubernetes, because otherwise, you know, you would re-implement it inside of ZEDCloud, and that's kind of pointless. So the distinction really, you know, sort of kicks in whether you have just a single container or multiple containers. And if you have just a single container, or maybe like a few to run, or a single VM or a few to run, you don't really need anything else but ZEDCloud. If you have, you know, complex topologies of containers that need to be executed on different types of hardware, then yeah, you would be better off running, you know, Kubernetes on top of EVE. You still would run it on top of EVE, and we actually have a demo of that, you know, coming up later. But it's a great question.